Welcome back to my channel. My name's Brian Kafiki, and I'm a data and AI enabler. And today we're going to be talking about using databases with R and ODBC. By the way, if you're on LinkedIn, look me up, connect, and just mention that you saw my video so I'll know why you're reaching out. So let's jump in. By the way, I also want to do a little bit of a push here. Wrote a book that just came out a couple of months ago, which is all about using Apache Spark. It's called Master Azure Databricks. Databricks is a wrapper service around Spark that enables you to use it more easily, but most of what the book talks about is also applicable to open source Apache Spark. And Azure Databricks is a specific implementation on Azure, and so there's some additional information about how to integrate and what those features are. So if you're looking at doing anything with big data on Spark, this is probably a good resource and definitely the most comprehensive I've seen out there. It gets into a lot of detail, lots of step-by-step examples, and it really takes you from beginning to end on a real use case. What is ODBC? ODBC is a way to get to a database. And this was a problem that happened a while ago. There was no way, every database had its own way to communicate and connect to it, and that became really expensive and difficult for product makers, vendors of things like Office or anything really, to read and use databases. So a standard was created called ODBC, Open Database Connectivity. So the idea here is you have a database, maybe you're this company AdventureWorks, and it's a SQL Server database. You want to get to it. Now this could be using Excel or any program. You want to be able to communicate to that database, read data, etc. But in your case, you have an R program, and you want to be able to read and write data to AdventureWorks. ODBC is the way to do that, and the language that it uses to pass things back and forth is, of course, structured query language. So a database really is, the API all databases really understand is SQL. But the protocol and the wrappers around it, how to get that SQL to the database and get results back, that's where ODBC steps in. It creates a standard for how that should be done so that you can have drivers that will all comply to the standard, and then it becomes more of a plug-and-play kind of situation. So again, it's called Open Database Connectivity, and it's a standard that most databases support. As I mentioned, in order to use it, you will need a driver that complies to the ODBC standards. And these are typically available for any database you can think of. The goal here is interoperability. You want to be able to work with different programs that can just read databases from different databases. Read data from different databases. All right, so I'm going to demonstrate the content I'm going to be talking about here is available on GitHub. It's at github.com/bkafiki/shared, and there's a folder called R-SQL ODBC. So again, all my content is on github.com/bkafiki/shared, but this folder is this, but there's other content out there as well, lots of stuff. I will try to remember to post this also in the description, but I want you to make sure you see this, so if you don't see it in the description, don't freak out. Just remember it's here and you can go out and get it. All right, to demonstrate how to use RODBC, I'm going to use the Jupyter Lab notebook. It's just a Jupyter notebook, and this is the newer version called Jupyter Lab. I'm going to warn you ahead of time that while I'm going to be including user IDs and passwords for demonstration purposes, that's not a good practice. Don't store passwords in notebooks and don't make it available. Obviously, those aren't things to be shared. And if you do use any of this code, it will be on, it's on GitHub for you guys to use. Just make sure you test it and it complies to your company standards. This is my sort of NDA or whatever. It's my way of saying I don't own this and I don't want to be responsible. You got to really make sure you're checking the code is doing what you want. This is really meant for demonstration purposes. I don't say that on all things, but when you're talking about getting to real databases, I want to make sure you're being careful about that. All right, so one of the things you will need to do if you don't already have it is install the RODBC package. And you can notice on this parameter in the first thing I say repos, I get errors if I don't give it a mirror to run. It used to work, but now it doesn't. So now I give it the mirror, which is in the US. There's a link below that. So this link here will give you the list of different mirrors, but just this is what I find. So if I do the install packages, this will give me what I want. Now I've already installed it, so I don't need to do that, but you may need to do that. So once it's installed, and by the way, then you have some information here. One of the questions you may have is maybe you don't have the drivers you need. So if you don't have the ODBC drivers, there's a link here. There, RStudio talks about some of those best practices for drivers. And for SQL Server, which is what I'm going to be demonstrating here, you can see there's a link for Microsoft ODBC drivers. Now the first thing I'm going to do is I'm going to create a function to simplify the access to the database, and you can feel free to clone, copy, and change this function. Just again, and remember, make sure it works to your standards. I'm going to require the RODBC package at the top, because without that, I'm not going to be able to do much. And let me sort of step through what I'm doing. So first I'm creating a function right here, right? And the function is going to take as parameters the server name, known as the host, the DB, database, and possibly user ID and password. I'm going to set up two different ways that the function can work. If you give it a password, then it will assume you also gave the user ID, and it will connect with what in SQL Server terms they call SQL Server authentication. But if you didn't, then it's going to assume it can use Windows authentication, or also called integrated security, and that will basically use Active Directory to say, yep, you have permission. Now, if you're using some other database, that wouldn't work. So you'll have to figure out, what makes sense for you. And this is specific to SQL Server, but it's not really anything special to change it. If you want to change it, all you got to do really is change this to whatever database you're interested in having. And of course, you could make that a parameter and plug it in as well to the function. But I'm making it a little more rigid because it's just easier to do it this way and show you what I'm trying to convey. All right, so let me clear that up and exit. Let's walk through this a little bit. So one of the first things I'm doing, well, I got rid of that too soon. I wanted to show you is this if is null.pass, pass is password. So if that is null, then all I'm really going to do is I'm going to make the connection with this logic here without the user ID and password, okay? But if you did pass the user ID and password, you can see here it's going to use this, and the user ID and password is being used. So it's a sort of branch here. It's just if-else type of thing, and it's going to use one or the other. And we'll see that in use. All right, so that's all really going on there. Then it just is going to come back with a message, yay or nay, did it make the connection? First thing I'm going to do is connect using integrated security. So with a really fancy naming convention, my IS connection, my integrated security connection, call the function. I'm going to be passing the name. Now mine's a little convoluted. Most people could just say localhost, but I've got all these different installations on my machine. So it's called my desktop PC name, SQL 2017. That's the version I'm running, 2017. And you can see the AdventureWorks DW 2017 is the database name. So before we go too far, if you want to replicate these queries and use them, you're going to need to get and install the AdventureWorks database. And that's available for different versions, flavors, 62-bit, I think, and all that stuff. But also, it varies depending on version of SQL Server. So I'm using 2017. You also see a 2016, a 2014. So whichever one you need, get that one. You may have to make slight coding changes. I don't know if it's compatible with my queries exactly. So columns may have been renamed or something. I wouldn't worry too much about using AdventureWorks because the main thing is you can try your own stuff, right? So just change that to whatever database and server you have, and then write queries that make sense for you. I personally would probably go that route. But if you really want to play with it and use AdventureWorks, then it's great as a way to learn and play, and it's available online. So just go do a web search for that, and it's easy to find and install. All right, so I'm going to do my connection here. Shift-Enter will let me run that cell. And then I'm going to run, I want to just kind of walk through this a little bit here. I'm going to run a function called SQL Columns, and I'm passing in SQL Columns the name of the connection and the table name, right? And you can see there, DBODIM date. So what I want to do is get a list of columns. Now I've wrapped this in the head function, so I'm getting just a few rows. And the nice thing is, head's just going to return a subset of the data frame. And lo and behold, it worked. You're getting column names, you're getting the types and lengths, etc., which is kind of handy. I always forget when I'm working with databases, like what are the column names? I'm trying to write a query, so that's a nice quick way to get a list. Now, when you're done working with connections in databases, it's really important to close them. So I'm going to run this statement here, which will close my connection. Otherwise, memory is being held up, and you can kind of tie things up in the database, and you don't want to be doing that. The reason I'm doing that is I wanted to open up a different connection, and this time creating my SS connection, which is SQL Server connection, And this time you can see I'm passing these, but I'm also passing username, password, right? So it's the same, except this time I'm using SQL Server authentication. So let me run that. Okay, and now I'm going to just run a little query and see if it worked. And sure enough, I'm able to run this top 3 product key, product subcategory key, English product name. And notice I can do things like, say, rename a column. Now, one thing also you'll see is it says top 3. Top 3 is a T-SQL specific dialect syntax. And I wanted to highlight that because when I'm using ODBC, I'm really just taking whatever SQL statement I give it and it's going to the database. And the takeaway from that is you can leverage the syntax of that database. Sometimes if you use things like ORMs, like SQL Alchemy or one of the others, it may be not directly passing things through. I think SQL Alchemy is pretty good like that. Django's ORM, I'm not so sure. But ODBC is pretty much a light veneer. You're just getting the connectivity and then you pass the dialect of SQL you want through. All right. And here I can do another SQL columns just to prove that's all good. That's a good way to make sure things are working. And here I'm going to run a query, and I'm just selecting top 5, product key, subcategory, etc., etc. A couple of things to point out are some parameters which are optional, which is rows at a time. I don't need to pass that. It will do, the default is 100 anyway, but this is to say if you're having trouble getting the rows back or something, you can change it to less rows to make sure you get what you need. And I can also say errors equal true, which means if an error occurs, stop everything, give me an error message, and report the error, that kind of thing. All right, so let me run this. And that's about it. There's a description here of what's the reason for rows at a time. My original thinking was more for performance, to be able to say, okay, give me 100 rows at a time, and maybe for a web app I could display them. And maybe it works like that as well. But here they're describing it more as like you're having communication problems. All right. So now again, those are optional. Sometimes I use them, sometimes I don't here. So I'm going to run another query. And this time, notice nothing came back. That's because we're returning the results to an object, AW product DF. DF standing for data frame. So when the SQL query runs, it returns a data frame back. And that's good for us because now we can easily query the database, get a data frame, and then use dplyr or whatever we want, the tidyverse, and go to town on using those data frames. So it's a really nice, handy way to be able to use things. I'm going to run this. And then I can just do something like display parts of the data frame with a head statement. And I can, as I said, do anything with that. One of the really strong parts of a database, an enterprise type of database like SQL Server, Oracle, or DB2, or whatever you want to use, is that you can write heavy-duty queries, and you can take these queries and push them back to the server. Like, who's going to do the work? Do you want to do the work, or do you want to let the server over there do the work? Typically, enterprise databases are heavy-duty, right? They've got a lot of memory, hardware, etc. So it's a lot better to let them do the work. Not to mention, you don't want to try to be bringing down like billions of rows to your little machine. I mean, even if you have a pretty robust client machine, it's unlikely it's at the same level as a production SQL server. So why not let that machine do the work and only bring what you need down? So that's what this is about, kind of demonstrating. But I'm selecting from here, and I do want to kind of call out a few things. So I'm going to, here I'm doing a sum, right? So I'm aggregating, and you can see I'm also doing group by. And this is a great type of thing you'd want to push to the backend database. Can you imagine if there's like in a query 1 billion rows and you're trying to aggregate all the data to get a summary by some column? A lot of work. It's much better off to push that to the backend database and let it just give you the result. That's what SQL servers, any kind of database server, is really meant for. All right, so let me clear that out. And I'm just going to run this to save that query as a variable called SQL. Now I can run it, and you can see here it just gave me some rows back because I wrapped it in the head statement, but it did that for me. Now another thing I can do, which might be handy, this would rely on me having security rights in the database to be able to create objects, which may not be the case. However, if I do, I can create objects like views. Now a view is really just a named query. And so it's not saving the actual data, it's just saving the select statement that I give it. And the nice thing is, though, it will treat as if it will treat that select statement, the name of the view, as if it's a table in every way possible, except it will take a lot longer to get the data because it's actually going to have to execute all that logic. So that's the problem with views, but it can be really handy because maybe I'm doing all these joins and I'm reusing the same kind of, like in this case, an aggregated query over and over again. So a view at least makes it easier to do that. So I'm going to save it this time. But one thing to bear in mind is this won't return results. It's just going to create a view. So let me run that. And I can see if it created the view name is sales summary. And you can see there it is. It just ran the SQL query, sales summary. So this statement ran the query, but because at the top, I want to just emphasize that, because at the top I wrote this, it's not actually going to come back with results, at least not here. Okay, so now what I want to do is something similar, but I'm going to run a SQL query, and I'm going to return the results to a data frame. That's why I'm creating this object df, right? So let me run this. And what I'm going to do is I want to save this data frame to a table just to show you how easy and cool that is. But just in case that table already exists, I'm going to delete it, which is what this statement does. Okay. And now I can save this as a data frame. Now I do want to call attention to a few things here. So I'm using first my connection. SQL save is the function, right? And I'm going to pass the connection. My data frame variable. The name of the table to be called in SQL Server. Whether or not I want row names, right? The good old famous row names in R. You can eliminate that. And this should create a primary key if it says equal true. But I'm finding it doesn't seem to work. But you can try it, see if you have good luck. I put it in here just to show it for demonstration purposes. So that's all really going on there. So let me save that. Oh, I already saved it. So I think I already ran that statement. Okay. So now what I want to do is run a query seeing if that table exists. And there it is. All right. Now here we're going to do SQL query, drop the table if it exists again, but we're going to create the table a little differently. In this case, instead of saving it via data frame, I'm going to be saving it right here. One of these T-SQL has the support for a statement called into, and you can say just above the from statement, say into, and give it a table name, and it will redirect all the output of the query to that table. Now one of the things that I found did not seem to work was if I said create table name and then as and then do a select statement, which is the most common way you see in databases of doing that. I didn't seem to like it, but it allowed me to do this. So I'm going to run this and actually just saved it as a variable. Now I can run it. It gave me an error. I think I forgot to drop it. Yeah. So make sure you drop it first. I can skip over that, and now I can create it. So you'll notice if you're doing any kind of processes, like you want to have a notebook that does ETL work, always make sure the state of the objects is what you want. You may have to drop objects if you're recreating them or replace things. Otherwise, you're going to get, your notebook will crash, basically, get errors. So don't want that. Okay, and now if it worked, I should be able to query the table, and voila, there it is. I'm going to show you something else, and I want to create a separate connection. I'm using integrated security, so you can see here, same thing, integrated security. And this time, I'm using AdventureWorks 2017, not AdventureWorks DW. Why? Because I need to show you how to run a stored procedure. They're really powerful. Many times people need to run stored procedures from whatever interface, Python's, R, or whatever. And the problem is there are no stored procedures in the AdventureWorks data warehouse, but the transactional database does have them. So I'm going to connect to that database just so I can show you how to call a stored procedure. So let me clear this out. Create the connection. And then here I'm going to execute a stored procedure. And what this stored procedure does, you can see exec and the name of the stored procedure, USP, get employee manager. It's actually giving you the hierarchy starting with the employee ID, which is called business entity number. So starting at 10. So this person reports to this person, reports to this person. So just kind of showing you this is how you would run it. And this at business entity ID, that's a parameter that the stored procedure takes, so you give it a value. So again, that's pretty important to be able to do that. And then when you're all done, you want to close connections you're done with. So we're going to close that connection. This connection is closed, so we should get an error, and we did. But if you just want to close all connections, you can just do ODBC close all, and that will get rid of everything you're using right there. So we saw a lot in this notebook, I think. We saw how to connect to databases. We saw how to use integrated security or just user ID password connecting, which you could easily use that if you want to connect to Postgres or something else, and even use the same function. When it sees user ID and password, it will go to that. And just replace the driver with what you need there. So that should be pretty straightforward. We also saw how to query, pull out data as a data frame, take a data frame and save it as a table. Want to store procedures, create views, also create tables from data frames or create tables directly through SQL statements. So a lot of different things we can do here. I'm going to build on this to show you how you can create your own local data warehouse with something like SQLite and then pull data together and persist it. And then you have a really nice platform to sort of munge and data wrangle and do all the things you need to do to support your data analytics. All right, so again, github.com/bkafferkey/shared, and the folder is RSQL ODBC. So wrapping up, we talked about using Open Database Connectivity, ODBC, with R, and the package is called RODBC, which you'll need to install if you don't have it. And this gives you the ability to really connect with almost any database in the world, at least any popular database, using ODBC, because that standard is pretty ubiquitous among databases now. You will need to possibly find a driver for ODBC. That would be used pretty much by anything trying to connect to that database through ODBC. So if you're using even something like Excel to connect to the database, you probably already have the driver. The goal of ODBC is interoperability, and using R and ODBC together, you get a really nice synergy. It's a nice way to be able to get data from the world. I would be surprised if many R programmers have not used ODBC if they've been doing it a while, because most of the time data is going to be coming from relational database at some point somewhere. And so this is a really good thing to know. So I want to thank you for watching. Please like, share, subscribe, connect on LinkedIn if you're interested. Always glad to connect with people. Mention my channel. And yeah, buy my book. It's great. So thank you. Until next time, remember, we're all in this together. I'm pulling for you from the Red Green Show. Take care.